Hello, everybody. Hope you guys had a good weekend. Anything exciting happen? No.
Mother's Day barbecue.
Oh, that's right. Mother's Day. Yeah, true. Mother's Day is exciting. I actually also had barbecue for Mother's Day. It's pretty good. All right, let me go ahead and share my screen. We can get into it. There is the attendance code. If you want to go ahead and navigate to this thingy that I have here, the attendance, and just pass in 3643. That is the code. I'll drop it in the chat too. Okay. All right. So what are we doing this week? Well, what we're going to be doing this week is we are going to be primarily dealing with SQL. That is going to, and databases. That is going to be essentially the main point of this week. We're going to understand how SQL databases function, how non-relational databases function, what NoSQL is. We'll get some theory behind what NewSQL is, and we'll have an understanding of why databases seem to be such an important topic in the field of data science, or more generally in the field of computer science, because databases are pretty fundamental in terms of storing data. As one would imagine, databases store data, and as a data scientist, you primarily work with data. So it makes sense that you need to have some understanding of how a database works. Web development, or web architecture, also utilizes databases for specific data storage cases. So, for instance, something like Facebook or Amazon, or most companies store their data in some type of NoSQL, SQL, or NewSQL database. So we're going to understand that. Now, all SQL really is a query language. It's a structured query language. That's what it stands for, SQL. It was invented by IBM a while ago, and it basically allows us to perform fast functioning queries on databases. Now, SQL is the primary language used for interacting with relational databases. It is what you do if you want to pull information. Now, the general connection that this sprint has and that SQL has to a data scientist is that, let's say that there is some database that you need to have access to, or some data rather that you need access to. Well, you can access that through, and let's say you need to access it through a database. Well, the way you'd access that relational database is through some type of SQL command. And that's why, if you've seen a lot of different job applications, or you've applied to at some point in time, you can see that SQL is often demanded. And I think it is one of the primary skills that is demanded. And that is because SQL, if you're working for a company that wants you to do some type of data analytics on their stuff, well, um, chances are they're storing their data in some type of relational database. And if they're storing it in a relational database, you need to know SQL in order to access that data. Hence why it's so important to have SQL, or have SQL as a skill, because it's the way you typically access data in most situations. Yeah. All right. Now I've mentioned SQL, NoSQL, and NewSQL, and we'll sort of deconstruct those terms as we move forward today and this week. But for now, we're just going to be focusing on relational databases today. Relational databases and SQL go hand in hand. If you have a relational database, at some point in the process of you accessing that data, you are interacting with SQL, or the database is interacting with SQL. All right, so let's get an understanding of what we're doing today. So the day today is going to be an introduction to what SQL is, the basics of the structured query language, and it's relatively, I don't want to say simple, but it's more digestible than something like Python. Python has a lot of things that you can do with it. SQL has a lot of things you can do with it, but it's a lot more declarative and a lot more understandable in terms of the general syntax and what it means to write a SQL query. So yeah, Now, we're also going to understand the purpose of SQL joins, what where is, what select is, what limit is, what order is, what join is, getting just an understanding of some basic SQL syntax that you might need on the day-to-day basis. So before lesson, I hope you had the chance to check out the standard library that we're going to be using to use the database management tool SQLite. So what is a database management tool? We'll explain that. We're going to be using we're going to be using SQLite primarily today to understand how SQL works and create a simple disk-based database, which means we're not going to be connecting to any cloud services like we will tomorrow and on Thursday. Today, and Wednesday, we're just going to be storing a database locally and accessing that database again through SQLite. Um, yeah, and like it says here, it doesn't require a separate server process. So that's what a disk-based database is. Hopefully you had a chance to read the tutorial. And also, if you want a nice browser for SQLite, I'd recommend checking out DB browser for SQLite. Now, this isn't my immediate choice. I would choose something like DB Beaver or something like that, whatever it's called. Really, it's just nice to have some type of database management or some type of database GUI that sort of allows you to see the infrastructure of your relational database. Now, DB Beaver is nice. This one's nice as well. But this is the one I'm going to be using today because I think this one has some issues on Windows. Not entirely sure, but I'm just going to use this one for SQLite. It's easier to understand, I think. And then the live lesson task is going to be using SQLite and Python, showing how it interacts with Py modules, and understanding these basic syntaxes. Select, where, limit, order, and join. We'll also learn about how to use create table to specify a schema for our data and insert statements to put data into our table, as well as some functions. The assignment is going to be querying this RPG database that we have up here. Notice how it says .SQLite3. That's because this is a database. It's specifically a disk-based database, so we're going to download that. And then you're going to go ahead and perform these SQL queries and try and figure out how many total characters there are in this RPG role-playing game database, how many of each specific subclass there are, and stuff like that. So that's what the assignment today is, using your SQL knowledge that you learned and that you will study today for the assignment and reference the documentation and stuff to write these SQL queries and perform some queries on this RPG database. All right. Assignment part 2 is going to be making a database and basically using the buddy move holidayiq.csv and moving it to a SQLite, a .SQLite3 database. All right, so with that, let's go ahead and talk about what a database management tool is and what a database is. I sort of already mentioned it earlier, but all a database is a database is a database is essentially a collection of data that's stored in some specific way. It's either stored in a relational way or a non-relational way. This is where we have these sorts of um, the treeing off of two different types of databases. There's two different types. There's relational and non-relational. We're going to be talking about relational today. And relational primarily uses SQL to interact with it. So when I say SQL, that means that we're using a relational database. So if you're using SQL to interact with the database, you are using a relational database. You have to be. There's a couple other types of databases, and we'll talk about those when we start to talk about NewSQL, which I think is, it's not necessarily a new one, but it sort of combines the two types of databases. But again, we'll talk about that later on Thursday. But know that for today, we're dealing with relational databases. So everything I say today primarily pertains to relational databases. Okay? Does that make sense? Everything I say today is going to be in reference to relational databases. Is it pronounced SQL or SQL? Either works. I call it SQL. You can call it SQL too. It doesn't matter. People call it both. Okay, and then this other question, do you have a recommended list of add-ons, drivers, extensions, etc. to get with our stack builder for Postgres? Yes, but we're not going over Postgres today. We're going over SQLite, so I won't be mentioning these at all today. Like I said, we're just going to be using SQLite. Now, this sort of gets to a bigger question, which is, what is a database management tool? So I'm sure you've heard the terms SQL, MySQL, SQLite, MongoDB, DynamoDB, all of these different sort of terms. Like we have Cassandra, we have Neo, Firebird, MySQL, Postgres, Kubrid, SQLite, CouchDB, Mariah, all these different sort of database management tools. Now, what a database management tool is it essentially handles in terms of relational sense, remember that's what we're talking about today. If we're using a Postgres or MySQL database, what the management or SQLite, what the is doing, what the database management tool is doing, is it's basically handling our structure, our SQL queries. It's handling our SQL queries, our SQL queries, and it's handling our sort of database management. We send a SQL query or some statement. That's again what SQL queries are called. We call them SQL statements or just statements. We say, okay, we're going to send a statement to this database management tool. They're going to process the database. They're going to process it, and then they're going to execute that SQL on the database. And they're also typically handle the hosting of our database. So they provide the server allocation and server space allocation for our database, as well as the database management tool also handles stuff like assigning um, indices or assigning data values or basically getting our database up and running and doing all the back end internals for that kind of stuff. So the database management tool is essentially what it does, what it's called. It manages our database, right? It's a tool we use to manage our database management tool, right? So now MySQL and PostgreSQL use SQL. So does SQLite. Um, MySQL and Postgres are sort of utilizing non-driver or disk-backed databases. Instead, we put them up in the cloud, and then we access and make client-server requests to that database to get back information. SQLite is all stored on our computer, for at least today. We're going to be making a SQLite database, and then with that SQLite database, we're going to be referencing it from our local machine. So that is the difference in terms of SQLite, MySQL, and Postgres, and all these different database management tools have different ways in which they structure uh, the sort of the way they sort of set up the database for us. Okay. Um, Now some of them are very minorly, like Postgres and MySQL. There's not huge differences there, but they still differ. Um, so yeah, so that is a database management tool, and a database just stores, it's a base of data, right? But I'm gonna go ahead and ask you guys a question, and that question is, what is a database? What are some examples of a database and where they're used? What are examples of where a database might be used? And I just realized I didn't create a question thread today, so I'm gonna go ahead and do that. Banks, exactly. That's a really good one. Banks really rely heavily off of relational databases because it provides relational databases, and we'll talk about this on Thursday, are a little bit more protected, or I'd rather say robust, than non-relational databases. And banks heavily rely typically off of those relations, those secure connections. Store data gathered from website interactions. Yes, exactly. And going back to banks, actually, banks, they uh, they have a lot of data, right? And they need to make quick access to those data points. Well, relational databases are perfect for that. A library is a database. It organizes data by features. Yep, exactly. Everywhere that a batch of data is stored, blockchain, a database is a set of related keys and values, at least with extensible other databases that can be related to other databases and so on. Yeah, anywhere where we need a collection of tables that are interrelated and related. This is primarily related to relational databases. Like I said, that's what we're talking about today. Yes, relational databases create a collection of tables that are interrelated and related. Um, in professional online gaming, storing stats, scores, uh, yes. I guess it depends what aspect. I'm not a huge game developer, but they use a different sort of data storage. Um, which I'm not going to get into. Customers and customer purchases, and maybe not a different type of data storage, but it's a little, the nuances are a bit different. Customers and customer purchases, basketball players and their game season, career stats. Exactly. Yeah. If you think about monitoring, like let's say we have some online clothing store, their data, like the email of the user, the password for signing in, their recent purchase history, all that stuff is stored in a database. Then maybe they have another database, or another collection, or another table that stores the products as well, right? So all super important stuff to realize is that everything that you see on a website, or at least data wise, typically comes from some type of database. Any social networking site, yeah, Facebook, Twitter, Pinterest, they all use databases. Like Pinterest, do you know how many images they have? Do you know how that's stored? It's probably stored in a relational database, not a non-relational data. Maybe, I don't really know how Pinterest is set up, but I'd imagine they'd use a relational database, and it will basically store the pictures associated with the users, through like stuff like keys, which we'll talk about today. But all that stuff, right? All this stuff is stored. All data is stored typically in a database, right? Now, I'm going to stress one more time the importance of understanding SQL this week. SQL is very important, and I encourage you as we move forward, not just in Unit 3, but in Unit 4 and throughout your Lambda journey, I encourage you to continue to practice SQL because I can promise you that it is a very important skill that employers look for. So I'm going to say this again: practice your SQL and continue to practice your SQL. This is not a one and done kind of thing, guys. Neither is object-oriented programming. You should continue to code in an object-oriented program or manner, an object-oriented manner, as well as continuing to practice SQL, because you should not just be doing it this week. You should continuously practice SQL. Make time for it. Maybe use it in different projects. Again, SQL is important, super important, very important. Um, Now let's talk about what a relational database is. So let's go ahead and let's take an example. Let's take this rpgdb.sqlite3 example. So we have this database here, right? And it's managed by SQLite, right? SQLite is the database management tool, and it's managing this RPG database that we have. Well, there's a specific schema associated with this one database, right? And a schema, basically, if you just think about it, is basically the way that the tables and rows in the database is set up. It's the structure of the database. So whenever I say schema, just think of structure. I'm saying, oh, this database schema, I'm saying this database structure. All right. And if we go ahead and click on this PNG that I have here, it's going to be describing the schema of the RPG database. So I'm going to go ahead and click on this. This will give us a nice little layout of what, whoa, this is big. Can I download this? Oh, there we go. That's better. So this is the schema of the RPG database. So let's go ahead and deconstruct what all of this means. So you see these little blocks of things like this, like words, like auth permissions. We don't really care too much about this stuff. You guys are primarily going to be focused on this stuff down here. Don't worry about the stuff up here. This is more related to Django, um, which is something you'll learn about next week. I mean, not really, but you'll understand what it is by next week. Now, this is what you should be concerned with. We have character creator character, armory items, armory weapon, character creator necromancer. We have all these different like table names. That's what these are. These are all tables. You see, I have character creator character. That's a table. I have character creator mage. That's a table. I have character creator character inventory. That's a table. I have armory weapon. That's a table. I think you guys get the point. All these little blocks are tables. All right. And this is actually how it's laid out in the rpgdb.sqlite3 database, is we have all these different collections of tables, right? This situation, we have 3, 6, 9. We have 9 tables, at least ignoring the Django stuff. We have 9 tables in our database. All right. And these tables, if you can see by these little lines, are all connected. All right. We have all of these different connections that are taking place. We see the character created character, this character ID, which the IDs are we're going to call this a primary key. This character ID is a primary key. This ID is a primary key. This item ID is a primary key. These bolded things, these bolded columns are the IDs. And that's also what these are: character ID, name, level, experience, HP, strength, intelligence, dexterity, wisdom. Those are all columns. Okay. You can sort of think about this as just a bunch of different data frames. All right. Like same sort of idea, right? We just have a database. It's just a collection of data frames. Now, not specifically Panda data frames, but it's a collection of tables, right? This database is a collection of tables. We have 9 tables in total, right? And in these tables, we have columns and also rows, but the rows aren't depicted here because they're specific data points that that we only see when we're actually interacting with the database, but this is just describing the schema, and we don't really need to talk about the data points that are actually in the schema. We just need to talk about the tables that exist, the columns that exist, and the connections that take place. And you can see here we have the character ID, which it's bolded, so that's the primary key. Oh, and um, then we have the column names as well. Then on here we have the actual SQL type that is used when creating these column names. So we have integer not null. This is a SQL command, auto incremented, and this auto incrementation is handled by SQLite, which means that each time we create a new character row, a character ID will be generated for it, specifically one that's auto incremented. So it's sequential, right? Now, this name has a variable number of characters, that's what varchar means, and it can't be null. And the rest are integers, okay? So this just defines basically the type or the create table sort of or the syntax that was used when this table was created. So keep that in mind. So each one of these has different columns and different primary IDs. Mage PTR ID is the primary ID of character creator or character creator necromancer. These table names are horrible, but I promise you'll see worse in the real world. Now let's talk about these primary keys, right? So character creator character is the primary, or character ID is the primary key of character creator character. Gosh, mouthful, I swear. So character ID is what is basically sort of keeping track of each of these individual rows. When we add a new row or a new data point to character creator character, it is assigned a character ID. And that character ID, that primary key for the character creator character table, is what is keeping track of that row. And this is also the primary keys are what we are able to use to relate different tables. You can see here that I have a character ID that is, we have this little relation here that says character PTR ID. Now, these two are related in some sense. So the character PTR ID is the primary key of character creator mage, right? And basically what this is saying is that this is going to be referencing the character ID, and each character ID that is put into this table is a mage, and each character ID that's put into the thief table is a thief, and so on, cleric, fighter, and then yeah, those are all these character PTR IDs, which are going to be the same as some character ID we have in this character creator character table. This is sort of all the characters, and then these subtables are basically the pointing to which type of character the character creator character is. So mage, thief, cleric, fighter, and then we have this subclass called necromancer, and all of the character PTR IDs that are found in the um, all of the character PTR IDs that are found inside this necromancer table are necromancers. Okay. Now, if we come here, we have this character ID and this item ID. So this is basically relating characters to their armory, right? So we have one row that consists of an ID, a character ID, and an item ID inside this character creator character inventory. And that character ID is related to an item ID. So this character ID is going to have multiple instances of character IDs because they each have an item associated with the character or an armory associated with the character. Now, this might seem very abstract and difficult to comprehend, but as we move forward today, I think you'll start to get a better understanding of it. But as of now, are there any questions for what's going on? Is there anything that's confusing about this schema?
I have a quick question. So for the arms that are connecting to different tables, um, I noticed that some of them are different than others. Like what do they mean? Like for example, the character creator character table, when it connects to the character creator character inventory table, the arm like that's connecting them looks different from
Yeah,
some of the other ones.
yeah, definitely. So let me go ahead and explain that. So you can see here that the ID here isn't referencing character creator character, right? The primary key in character creator character inventory is not referencing the primary key of character creator character, right? So you can see this character ID is referencing the character ID, but it's not the primary key. It's a column inside of this character creator character inventory. I mean, the ID is as well, but these aren't primary keys of another table. Now, these these are if character PTR ID is directly referencing character ID. So that's why I called these subtables, is because this is basically sort of taking the information from character creator character, using the same ID, and creating a separate table using the same ID. It's basically just referencing the character, the primary key inside character creator character, and creating a sub table of that, which is why we have these little stoppers. Now, these little arrows mean that we're referencing or have a foreign key. Okay, so this is an important distinction that I was going to talk about later, but I guess I can talk about it now and just reiterate it later on, is that character ID and item ID are being referenced by character creator or character inventory, right? They're not using it as a primary key, they're just referencing another key. That's not necessarily what's happening here. What's happening in character creator character inventory, though, is that character ID refers to a specific row within character creator character. Item ID refers to a specific item within armory item, and it has a unique item ID and a unique character ID. Okay, so what's important to note is that these are called foreign keys. All right, so a foreign key basically means that it's a key from another table. Now, this essentially isn't, this character PTRID is not a foreign key. It's a primary key because it's what is being used to define the columns inside, or the rows inside character creator mage. ID is the primary key because it is defining the rows, or referencing the rows inside character creator character inventory. Now, I don't know if that, I hope that helped, and I can assure you that we'll be retouching upon this topic when we actually start to code some SQL. Right now, it's a bit more theory, but does that clear things up?
Yeah, thank you.
And then Paul said, why would you have a table with only one attribute? What do you mean? Oh, for this one, like up here, armory weapon. Oh, you're thinking of the necromancer and weapons. Why aren't they subsumed into mage and armory respectively? So there's a couple reasons. Well, at least in this situation, I mean, you could do that if you wanted. Really, the person making the database is the one who's in charge of the way it's laid out. And sometimes there's a reason, sometimes there's not. Um, Sometimes it's personal preference, sometimes it's not. Now, the reason character creator, character necromancer, and mage PTRID, the reason this only has one value, or one column, is because it's sort of doing a separation, right? Let's imagine, how would we sort of store character creator necromancer into this character creator mage table? How would we do that? We could have some maybe Boolean column that says whether or not it's a necromancer, right? Like we'd say, okay, some portion of character creator mage is a necromancer, so we're going to attach a necromancer question mark column that is related to a Boolean that has true or false, right? And then some portion of those are going to be false and some portion of them are going to be true. The ones that are true, we're going to also have some column called talesman charged, and that column is going to either be null or have some value depending upon whether the necromancer column is true. That's being a bit redundant, or that's storing unnecessary information that you don't need, right? Because we're storing nothing and false, and we don't need to store that. That's a waste of space. That makes sense? We don't need to.
Yeah,
Yeah.
it absolutely makes sense. I was confusing. I was under the impression that every mage had that attribute of talisman charged or not, but it makes sense if it's a subset of that data,
Yeah.
that it would only, yeah, okay, that
Yeah,
would work.
similar to, and that's what these little these stop thingies mean, like the circle and the stop. That means that it's a sub, like it's included, it's a sub table. Like character creator character, all four of these different classes, mage, thief, cleric, and fighter, all store some portion of the character creator data in it. And then necromancer stores some portion of the mage data. Same with our armory weapon. Armory weapon stores some portion of armory items. Not all the items are weapons, but the item IDs that are stored within the armory weapon table are weapons. So it's a sub table. Does that make sense? Cool. Okay. Now, let's go ahead and take a 5-minute break. And when we get back, we're going to go ahead and start coding some stuff. So I will see you when we are back. Okay, so let's go ahead and start some coding stuff now. All right, so I'm going to go ahead and navigate to iTerminal, or your terminal, and I'm going to be creating a new folder for this week called DS26. And I'll be doing the same thing I did last week, which is pushing this to a repository and sharing that with you guys so you guys can have my code throughout the day. So I'm going to just go ahead and navigate to DS26. I'm going to go ahead and make a directory or make a folder. Let's go ahead and make a folder and we'll call it module 1. Okay, I'm going to go ahead and cd into module 1, or first, how about we go ahead and create a pip environment. So I can see I'm next to module 1. I'm going to go ahead and just say cat, or not cat. Oh wait, we don't even really even need to create a pip file today because we're not using anything other than SQLite. And SQLite is a part of the standard library. If we go ahead and just type Python, I do import SQLite. You can see I have SQLite 3. So I'm going to probably format this later when I push it to GitHub, but for now we're just going to go ahead and have module 1. I'm going to go ahead and change directories into module 1, and we're going to create a new file called example or SQLite example.py. All right, cool. So before we begin, I'm going to go ahead and show you guys how to do this stuff in the REPL. And I'm going to open this up in code first. Put it over there. And now we're going to go ahead and mess around with SQLite in the Python REPL. So I'm going to go ahead and do that. I'm going to import SQLite 3 because if you remember, it's a part of the standard library. Now I have SQLite 3, and I have a bunch of different stuff with SQLite 3 that I can do. Go ahead and take a look at SQLite 3. You can see I have all these different things. We got connection, cursor. I'm going to want to use connection to connect to a database. Now there's something else that we need to do. Now remember, SQLite isn't making a client server request. Instead, it's just referencing the disk database that we have. And we don't have the database in our location, right? If we go ahead and if I open up a new window, and I navigate to where we currently are, I don't have any RPG data that I'm referencing. I need to actually, I need to download the database. So let's go ahead and do that. So let's go over to the REPL or the GitHub, and we're going to go ahead and download this database. So I'll come back to module 1 introduction, and I'll share this database with you guys as well. First, I need to download it. So I'm just going to go ahead and hit like view raw. It's going to download the database, and then I'm going to want to move that to this location. So I'm going to go ahead and I'll create a new folder though, and we're going to go ahead and say make directory data. So I now have a data folder. I'm going to go ahead and do that, and then I'm going to take my RPG data and move it to that location. So I'm going to open up another terminal. I know this might get a bit annoying. Something you should get used to though. I'm going to go to downloads, wherever yours is stored, and I'm going to move the RPG data.sqlite3 to this location. I'm going to print a working directory. This is how you move files, MV. I'm going to go ahead and do that. And I now have if we go ahead, check here, RPG data.sqlite3 in my data folder. Cool, so I can close this terminal, clear this up, and close this terminal. So I now have, if we go ahead and try and make a connection, I should now be able to connect to that database I have there. Let me go ahead and exit out and show you that it's there. So you see we have SQLite example.py. If I change directories out, I now have data, and I change into data. You can see I have my database there. Fantastic. So let's go ahead and do this. Let's connect to our database. So I'm going to say Python. I'm going to go import SQLite 3. And I'll give you guys a second to catch up. Notice that I've activated my REPL in the data folder. Otherwise, I'll have to point to it directly. So make sure you're there. All I've done is move my file. I'll give you guys a second to catch up because you're probably, I don't want to say that maybe you're not as quick as me, so I'll wait a second and let you guys catch up. All we've done is move rpgdb.sqlite3 to a new data folder next to module 1, and then we've gone to the REPL inside of that data folder. Okay, so there's a few steps we need in order to connect to our database. I'm gonna just list them out here, say step 1, connect to database. Seems to make sense. All we need to do that is call the method SQLite3.connect, and then we pass in the name of our database. And since we're in, or not the name, the path of our database, and since we're currently in the data, the folder that it's located within our REPL, we can just say rpg underscore db.sqlite3. Okay, and this will connect to our database. If I hit enter, you can see I now have a connection object returned. We need to go ahead and say, let's store this object as something. Let's store it as con. So we're going to store our connection as con. So we got back a connection object. Now I have con there. So SQLite3.connection object at blah, blah, blah. Perfect. So now we're on to step 2. I'm going to share this code with you guys though. So I'll explain exactly what's going on here in a moment after I've created our cursor. So step 2 is going to be making a cursor. And we just make a cursor by saying, say curse equals con.cursor. This is referencing the cursor object we have and calling the cursor method. So now we have a cursor and a connection. So what does that mean? Why do we have those? And what's the point? Well, we've connected to our SQLite3 database. And what this connection basically, you can sort of think of it as, is sort of we've created an open link between me, in this situation, my computer, my REPL, whatever you want to say. We've created a connection between, right here, between this connection object and my SQLite3 database. Now, for instance, these are both stored on my computer, but you could imagine that, let's say this database was stored in the cloud. I'd be creating a connection between my computer, or my SQLite module uh, and the database that's stored in the cloud. In this situation, it's just stored on my computer, and we're just referencing the rpg-db.sqlite3 database on my disk. So it's just my computer is connecting to my computer, essentially. My SQLite object is connecting to my um, rpg-db.sqlite3 database. So we've created this connection here. And what this basically means is we can now interact with it because we've opened this connection and stored that connection in a connection object. Now we've created a cursor as well. And what this cursor basically does is it basically takes the things that we want to do and swims or goes through that connection or whatever, and interacts with the database, and then it comes on back and interacts with us. So a cursor is basically the thing that is iterating over the database, or the thing that interacts with the database. We call it a cursor because, we have this mouse cursor right here, right? And what does it do? It allows me to interact with my computer, right? If I click on something, I come down here and I want to listen to some music, I click on Spotify, I use my cursor to interact with it, right? This is a cursor. Now, a cursor does the same thing in terms of a database. Cursor interacts with the database. It's the thing we send SQL queries on. It's the thing we, use to send something over a connection. It's what we throw our statements on. It sort of, let's imagine we have some SQL query. We throw it on the back of a cursor. The cursor goes up, interacts with the connection or the database, or goes through the connection, interacts with the database, and comes back through the connection and gives us the results, right? That's what a cursor and connection do. Any questions about that? No? All right, cool. So that means we can move on to computer 3. Computer 3, or wow, step 3. Step 3. See, I wonder how many of those little like accidental slip-ups I have that I just don't notice. Like saying computer 3 instead of step 3. I bet they happen all the time. And my bad if they do, but I just wonder how many go uncaught. All right, so we're gonna go ahead and do step 3, which is write your query. So we're writing a query. This needs to be a valid string, in order for it to be a SQL query. So we're going to go ahead and say write your query. This query is going to be something that allows us to interact with the database. So I'm going to go ahead and say, I'm going to go ahead and say select star from armory item, or let's do from character creator character table. and we need to finish it with a semicolon. So this is one of the most basic SQL queries that you should know. This basically just says select everything from character creator character. Now that's a table we have, right? I'm going to go ahead and open up this database in DB browser. So let me go ahead and do that. You don't necessarily need to follow along here, but let's take a look at what we got. So basically, we have all these different tables, right? And this is our schema. So this is just giving you an overlook of what DB browser looks like. So this is our table. We don't really need to worry about these indices. And we can see if we click on our memory item, we have item PTRID. We have this yellow key here. That's a primary key. If we go here, we have a primary key, two silver keys. Now let's go ahead and check, and silver keys are foreign keys. Let's go ahead and check out, if we were to look at our schema, you remember that the character inventory has two foreign keys, character ID and item ID. Those are foreign keys. The primary ID is the gold ID column, right? If we go to character creator character, right here, you can see we have character ID and then a list of different columns. Now this is under database structure, so database schema, the schema of the database. We can also browse data. If we want to go ahead and check out character creator character, we can see that we have all these rows. We have approximately 302 rows inside character creator character table. These are the rows. You can see each one has a character ID. Each one is being auto incremented because remember that's what initially was said. If we come here, we can see the actual SQL query that was made in order to create the table. Character ID, primary key, auto increment. So that's associated with the character ID. Now we have 302 rows. We can edit. We're not going to actually focus on that. And then we can execute SQL over here. So if I go ahead and say select star from character creator character, you have to always finish your SQL queries with a semicolon as well. So in general, the SQL commands such as select and from are reserved words used by SQL. So anytime you are using some SQL command, you should capitalize it. All right. So you can see here I've capitalized select and I've capitalized from, but I did not capitalize the table I'm referencing. Only capitalize entirely. Only uppercase the entire word if it's a SQL command. So if we go select star from character creator character and I hit play on this or enter or run or whatever you want to call it, you can see that I have got all of the data rows from my table, right? Specifically from character creator character. So I'm saying select everything from this table. Now I could select specific columns by saying we just want to select name, and let's also just select level. Notice how I have a comma there as well. If I just do that, you can say get back just the name and level. If I wanted maybe the character ID as well, I could do that and get the name and level. These are all coming from character creator character. Star just basically says we want all of the columns name, all of the columns printed out. Character ID, name, level experience, all of them, right? If we go back to browse data, you can see that those are all of the columns we have. Oops. Go to database structure, you can see that if I click on character creator character, you can see I have all of these column names. Those are the ones I get back when I select all of the columns. All right. So we're going to go ahead and make that query. So I'm going to go ahead and say query equals select star from character creator character. Then after that, I'm going to go ahead and execute my query. I'm going to say step 4, execute query. So we're going to go step 4, execute query. I'm going to go ahead and enter on that. And we are going to go ahead and execute this query. So we do that by doing curse.execute. This will execute a SQL query, and then we just pass in the query itself. All right. So we're just executing this query variable we made up here called select star from character creator character, which should give us back all of this. So if I go ahead and hit enter, you can see I get back a cursor object. That means that it was successful and the query was executed. Now step 5 is actually retrieving this data. So I'm going to say retrieve data on the back of the cursor. That is on, and that's on the back of the cursor. So we sent this SQL query to the database, it was executed, and now the cursor came back. Now we need to actually fetch that data, and we can say results equals curse dot fetch all. This will fetch all of the values that we got back. If we go ahead and enter and do the length of results, what do you expect for this to get? We should get back 302. And we do get back 302. And if we go ahead and take a look at just the first 5 values of results, we can see that we have it in a list. If we do results 5, you can see we have a list of tuples. Each of these tuples is basically a row, and this list is all of the different rows we have, right? So if we do results 5, we have 5 tuples here, 5 tuples. The tuples, each tuple is corresponding to one of these rows. If we check the 5th one, you can see we have at id ruconsan. This is fake Latin. With all of these different values specified. And if we just print out all the results, you can see I have every single value, all the way 302 tuples, each tuple pertaining to one of these rows, right? Now, SQLite sort of handles this formatting. It sort of makes the request, and then when it comes back, it puts it in a nice Python type, in the situation, the list, and tuples. So we just made our first SQL query. Fantastic, guys. Give yourself a pat on the back. We've just wrote SQL for the first time. So, any questions about that at all? Do we need to download that DB browser, or can we just use CLI? It'd be nice if you guys downloaded the DB browser, because I think it would provide you a nice little graphical interface to write queries and to see your data just starting out. I don't really use them too frequently. It depends. Sometimes it's nice to have. Actually, what am I saying? I use them a good amount. Yeah, you should typically download a database management graphical user interface just to see what's going on. It's nice to have. It's not going to be a pain. Yeah, as Brody said, it's really nice to have. Yeah, it's not required. Like, this is just a massive convention. Like, if I do select star from character to character, notice how the dark blue is SQL commands. I run this, it'll work perfectly fine. It's just like PEP 8. It's like some grammar that we should follow when we're writing SQL. You should really follow that one. Now, also, you should also always end it with a semicolon. 2 things super important that you need to do. Capitalize the SQL words, put a semicolon at the end of your statement. You need to do that. Like there's not much syntax. I mean, there is a lot actually that I'd say is really important, and this is one of them. Select and from and all the other SQL syntaxes or commands should be uppercase. And you should finish your statement every single time with a semicolon. Same sort of idea with JavaScript if you've ever written JavaScript. Finish your line with a colon or a semicolon. That more pertain to JavaScript, but finish your statement with a semicolon. So I could go like this. It doesn't have to be one line. Just if you're making a SQL command, make sure that by the end of it, you have a semicolon at the end. Okay? I mean, this works too. It still will work without the semicolon, but it can be very annoying if you start to bundle together different statements, and it's an anti-pattern that you should not fall into. Do not exclude the semicolon. Okay, so we've done that. Let's go ahead and show you how this would function in something like a Python file, right? So let's go ahead and exit out of this REPL, and let's pull up VS Code. So please navigate to VS Code, and we're basically going to be doing the same steps we did here. So what's the first thing I did? I'll let you guys a second to navigate here. I'm just inside module 1. What's the first thing we did? All we
Connect
did,
to a database.
yeah, connect to a database, or well, actually import SQLite 3, because we need that first. But yes, then we connect to a database. So import SQLite 3, and I'm going to go ahead and give a little doc string. We'll just say all right, so let's connect to our database now. I'll just go ahead and say step 1, connect to. All right, so we're going to do that just by saying SQLite 3 dot connect, then passing in the location of our database. In this case, it's stored in data, so we're just going to go one directory up. We're going to go into data, and then we're going to grab SQLite or db rpg underscore db.sqlite3. Now, this is going to highlight a very important point that I want to show. So what happens, let me go ahead and go into Python again. What happens if I misspell something? Let's say let's import SQLite3 again, and let's say that I want to connect to another object. I want to connect to another database. Or let's say I want to connect to RPG database and I've accidentally misspelled something. I'll say connection equals SQLite3 dot connect. And let's say that I accidentally misspell RPG and I say rpdb.sqlite3. Do you think this will spit back an error? No, it won't spit back an error. What it's going to do is if you don't have a database with this name in the location that you're trying to create it, so in data right now, because that's where the Python REPL is at, as you see here, then it's going to create that database. And this can cause a lot of issues. And I'll explain why this is people have a lot of errors associated with this problem right here. So please listen up. So I've created this database, right? Because it doesn't exist yet. If I go ahead and open up a new terminal, I go ahead and navigate to where we currently are. Gosh. You can see I now have an rpdb.sqlite3. And if we go ahead and try and, let's make a cursor and try and connect. And let's execute a query, say cursor.execute. Notice the semicolon. No such table character create a character. Now, why did this happen? It's because we're not referencing the RPG database with our connection. We're referencing a new one that we made that is completely empty. So if you get back, and I'm going to say this twice, if you get back an error saying your table doesn't found, your column isn't found, this row doesn't exist, the database isn't alive, make sure that you are connecting to the right one. Make sure you haven't created another instance of your database, because what happens is you think that you're in the right path. Like let's say that we're not in the right data folder, we've done this wrong, or we've gone 2 directories up somehow and we expected it to be here instead. Well, what's going to happen is it's going to make that database. It'll make this database in that location. So let's say instead I just did this. I just did rpgdb.sqlite3, and I'm not specifying that I want to go into the data folder. It's going to create one right in the module 1 folder, because that's where the SQLite example.py file is stored, and that's the relative path if I just don't provide what I'm trying to reference. So keep that in mind. Make sure you spelt it correctly. That goes for everything in this path, because it will make a data folder for me. All right, so connect. There's a message in the chat. Oh, literally what you did 5 minutes ago. Yeah, very, very, very common mistake. Make sure you're in the right location. Now, if you didn't get back this and you got back to table user doesn't exist, then you probably didn't connect to the right database. All right, so with that, let's go ahead and we've connected to our database. What's step 2? Let me pull up slide. What is step 2? All right, step 2. Oh, geez. Step 2 is going to be step 2, make a cursor from our connection. So we just say, we got to store this as a connection object, right? So con equals SQLite3.connect. Then we do cursor equals con dot cursor. And then what's step 3? Step 3 is write your query. And we'll just say query equals select star from character creator character semicolon. Then we're going to execute our query doing pretty much the exact same steps. All right, we're going to say curse. I'm going to store this curse instead. Curse dot execute query. We need to store that as something. Or actually, we want to get the results first. My bad. So we want to say step 5. Fetch results. And we're going to fetch the results just by saying results equals curse dot fetch all. All right, cool. So this has the results from our query. Then let's go ahead and print out the results and run this file. All right, let's exit out of this. Clear this up. And let's go ahead and run this command. I'm going to remove this database we made, RP. I don't have it anymore. Then we'll go into module 1 and we're going to run this code by saying Python SQLite example.py. Boom. And look, we printed out all that data. So it works exactly as intended. Cool. So we just did it basically in a Python file. I just said Python SQLite example.py. Now, what's probably a better workflow is what if we made a function? What if we started using some of our object-oriented programming skills to make a connection object and get this thing up and running? So we could do that. We could maybe inherit, or maybe we want to create a function. We'll just do some functions and show you guys a basic workflow. Just go ahead and make a function and say connect to DB, DB name equals, let's just give it a default value of this. DB name. Maybe we want to return a cursor too in this connected database. Or how about we don't, because we want to make an actually set. We're going to close the cursor. Okay, so I'm just leave it like this. So I'm just going to return a connection object. All right, we could even in fact just make this a lot simpler and just say return SQLite3.connect. Now, this might not be the best idea because really it's not really a point creating it. But essentially what I want you guys to realize this week as well is that the way I'm doing it does not you don't have to do it that way. Maybe you find something better. Maybe you want to do something else. Go ahead. Really, it's very, 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 a lot of this is very open-ended in the sense it's like you write it in the way that makes the most sense. You write it in the way that, you know, you feel the most comfortable with. There's not really, I mean, there's a wrong way to do things, but there's not necessarily one right way to do things. There's many right ways to do this. So keep that in mind. And we're going to go ahead and make a cursor from our connection. So let's just go ahead and say DEF. Let's just say execute query. So we're going to want it to execute a query and return back some information. So let's go ahead and, stop it. We're going to go ahead and create a cursor. So we're going to go ahead and say it takes a connection object, let's say, and it takes a query. And let's say we make a cursor. Cursor equals con.cursor. And then we're going to say curse.execute, execute a query, and then fetch everything. And we'll return this. Feeling comfortable with that? Does that make sense? And then how about we go ahead and close the cursor as well? So I'm going to go ahead and say results. And then we're going to say curse.close and then return results. It's a good practice to close your cursors because with some database management tools, there can be some issues with having too many cursors. You might be restricted by your free access. Some other issues might be, you don't want to just leave a bunch of cursors open if you're keeping connection open. Be kind of annoying and pointless if you had 50 cursors all during one connection phase of your database. You don't want to do that. Make sure you close your cursors after you maybe perform the query that you wanted to, or after you're done performing the collection of actions that you want to do. So keep that in mind. So we're going to do that, execute query. We've gone ahead and basically wrote a function to execute any query we want just by passing in a connection and a query. So let's go ahead and create a query next. Let's write a query. I'm going to go ahead and I guess these are sort of all steps that happen inside this function. All right, now we're going to do step 3. And step 3 is going to be writing your query. So we're going to write this query in a separate file. I'm going to call this file query.py. All right, and we're just going to go ahead and take this query and put it here. And we'll say select characters. And then we can come up here, we can say import or from query import select characters. And then we can go down here and we can say, all right, let's execute a query. Say if name equals main. We are going to go ahead and execute this query. And we need to pass in our connection that we're going to make up here by saying con equals def or equals connect to db. And we'll just leave it as the default name we have. All right, let's see if this works. I'll share this code with you guys. Fantastic. Let's go ahead and give it a run. If I clear this up and I say Python SQLite example.py. Well, we should probably print something out. I'll store this as characters. I'll do print characters. Boom, I got back all the characters. Fantastic, so it's working as intended. Now, it's important to note that there's a couple things that is wrong with this. And we'll build off of this later on. But what you should realize is that this execute query function is going to give you some errors if you try and do 3 out of the 4 database operations. Now, speaking of which, this is going to lead to a nice tangent that about CRUD operations. So what CRUD operations are is CRUD operations are basically what you can do on a database. We got create, read, update, and delete. And it's 4 basic operations of persistent storage, of database storage. And they are everything you can basically do when it comes to creating or when it comes to interacting with the database. We can either create information, we can read information, which is what we've been doing. If you remember, we've just been we haven't really been modifying it. We've just been getting back the characters from the creator character table. So we've only been doing read operations. We haven't created anything. We haven't updated anything. This allows us to update already existing data points. We haven't deleted anything, which, as I'm sure you can infer, deletes data points, deletes information, deletes really anything. So creating, reading, updating, deleting, CRUD operations are all things you can do on a persistent source of storage. Now, we are going to run into an issue when we have this execute query function that if we create, update, or delete something, we don't necessarily get back results. We can't really fetch anything because we're not performing some type of read operation. We're not reading from the database. We're actually modifying it. We're going to get back a different object here, and we're not necessarily going. We're going to get back a different object when we actually do curse.execute query. We're not going to be able to fetch anything. We're going to get back a success, basically a success object, basically saying whether or not that the actual query itself succeeded with create, delete, and update functions or operations. we only can use fetch all when we actually have read something from the database. So if we try and pass in something like a create table statement or an insert statement or a delete statement or a drop statement, we're going to get back an error because we don't have this fetch all method on that result that we're getting back from the curse.execute method. So keep that in mind. Now, again, that's something we're going to focus on later on, but realize that you might run into an issue if you try and use any of the other operations on this function. So any questions about this though? Then we're going to go ahead and actually start creating a, going to actually start messing around in DB browser and writing some SQL queries. But this is a very, very general workflow for what it could look like. So let's go ahead and I'll create a step 3 over here. We'll call it all right. I'll go ahead and update this. All right, any questions? There was a mosquito over here and he keeps trying to bite me. It's getting really annoying. Leave me alone. Gosh. All right. Oh, I accidentally deleted the slide. Oh, that's not what we wanted. No questions? That's good. That's good. All right. If there's no questions, let's go ahead and go to DB browser. And what I want you guys to focus on, we're going to take a 5-minute break before we do this, is making sure you have access to some database browser, whether it's DBbeaver, or whether it's DB browser. So just make sure you have one of these installed and then open your database in it. And when we get back, we're going to just practice some SQL queries and some syntax in here to show you what a SQL query looks like and give you guys some understanding of what limit is, what where is, what select is, what from is, all that stuff. So we're going to learn SQL in the next 45 minutes. So go ahead and please do that while we are gone. I'm going to go ahead and focus on killing this mosquito. So I will see you in 5 minutes. Okay, so hopefully you had the chance to download DB Browser. I killed my mosquito, so it's good. So, all right, let's go ahead and navigate to DB Browser. Hopefully you had the chance to pull up the database stuff, the SQLite RPG database. I guess, are there any questions first about anything we've been doing? No? Okay, cool. I'm gonna go ahead and create a separate thread here too for SQL queries. All right, and this is going to house the queries that I'm going to be writing today. So one of the first ones we've done is select star from character creator character, right? With the semicolon. Let's go ahead and run this. You can see it just gets back all that, right? So we know that one. Hopefully by now, I'm gonna go ahead and post that here. Cool, we know that one. Now, let's go ahead and do another one. So we're gonna go ahead and add another query to this, and that query is going to be, let's go ahead and let's say we wanted to see how many values or how many rows we had in this database. What we can do is use something called a count. We have functions we can perform on these different columns. In this instance, we can perform a function on each of the rows. And we got a message in the chat. Can you zoom in? It's hard to see. Thanks. Yes. How does one zoom in on this? Command plus, Command Shift plus, Control plus, Command plus, Control Shift plus, FN Control plus, Option Control plus. All right. Well, it seems. Does anybody know how to zoom in?
You can change the font size in the preferences. That might be good enough.
Okay. Ah. All right. It affected everything except the. Cool. Yeah. Everything except. Okay. Well, that's kind
Sorry.
of no, it's fine. That's kind of annoying. Why would they do that? All right. Well, I'm sharing the commands in the channel, so I hope that makes life easier. Um, can you at least can you see most of it? So let's go run this again, see if it fixes this. What did it do to the formatting? Oh my gosh. Yeah, I would recommend using DB Brow or dbeaver instead of DB Browser. This thing gets so annoying sometimes. I don't really use Postgres or I don't really use SQLite, so I haven't really had to deal with this. But
It's in the SQL tab in preferences to change the font size for these other two things in case.
thank you. This one, general, that makes
So there's
sense.
an editor font size and results font size are two separate guys.
Awesome, thank you so much. All right. Do we have like timed Roman or something? Cool. SQL font size. Okay, that's looking a bit better. Cool. Thank you for that. I don't know why it formatted these so weird. All right. Cool, that's better. There we go. Thank you for that, Paul. Appreciate it. I think that was you talking. It sounded like your voice. Cool, so we got that. Fantastic. So we now have select star from character, character, character. Hopefully you can see that. But we have this aggregation function called count. And this basically, if you see here, it says count the X function returns a counted number of times that X is not null in a group. So this does not return null values. So I do select count star from character, character, character. We should get back another table that's 302. Why is this formatted so weird? This looks broken. What's wrong with this thing? I need a reset. I probably just need to reset DB browser. Yeah, this one's a bit buggy. DB browser is a bit buggy. Okay, but so we can select, we get back 302, and we see if we go back to data, browse data, we can see that that's how many data values we have, is we have 302 in a character created character. Yeah, 302. Perfect. Take a look at that. Fantastic. So if we go back to execute SQL, we can go ahead and see that what count does, what count star does, is it basically counts all of the rows from character created character. We could do the same thing on maybe the name column. And we get back 302 because there's still 302 values associated with the name. Now, if there was a null value there, we'd only get back 301. If there's two null values, we get back 300 because count does not count null values. We can use distinct, and distinct will return all of the distinct values of a column. So let's say we want all the distinct values of something like the name column. We go ahead and run that. You can see we get only the distinct names back. And we got back student ID and distinct name. We get back why are you just complaining at me? That should not be giving me an error. Oh, we want character ID. That's why. Cool. So we get back the name and character ID, and you can see that there's 302, right? Okay. So let's go ahead and maybe we want to just see the distinct names, and perfect. All right. This is really frustrating me. I don't know why it looks so bad. All right. Now that we've done that, let's go ahead and see some other ones. So we have count. Maybe we want to count just the distinct names. We can stack these functions, such as saying count distinct. We can run that. We see we get back 297. So that's interesting because in total we have 302 rows. So that means that there's only 297 distinct names, which means there's 5 names that have the same value as one other name in our actual table. So select count distinct name counts the total number of distinct names, right? It's very declarative. It's very it's very readable. You can say select count the distinct name from character created character. SQL is very easy to read. Now we can also do some other stuff. We can maybe limit the total number. Let's just grab back all of the values, select star from character creator character. We can grab back a certain number of values. Let's say we want to only grab back the first 10. This is similar to something like head. I can say limit 10, right? And let me go ahead and post these in the thing as well. We can say select count star from character creator character. We can do select count distinct from character creator character. And we can do limit 10, which will just give us back 10 values. You can see we only have 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Fantastic. All 10 values. Maybe I want to do something like, let's grab back character ID. Just the character IDs, you can get back, I only get the character IDs, which go up to 10, right? So this is inclusive, so it'll give us back 10 values. This is something similar you guys have dealt with, like similar to head. You guys know head for the actual, it's bird is the 14% stressing emails out. Yeah, I should probably plug in my computer. FYI, if anyone else has a weird formatting, restore defaults and preferences will bring everything back to the way it is. Yeah. I don't think that's the issue though. Let's see, restore defaults. Oh yay, that did work. I wonder what format. Sweet, thank you. All right, let me go ahead. Paul coming in with nice little SQL DB browser things. Okay, let me restore this to 20. Save. Oh, but then it does that. All right, well, I guess I just have to deal with it. All right. Let's just try and do this one then. Okay, it's still going to give it to me. All right, well, Sorry for the ugliness. All right, so let's go ahead and we have select character ID from character creator character, limit 10. So we can basically do a head thing there. Go ahead and share this one with you guys as well. Cool. So we have that one. We can do, we can also use like conditionals. We can use stuff like where to sort of sort specific information. So let's say we want to grab back everything, select star from, and you can notice how I'm starting to put these on new lines to make things organized, which is perfectly acceptable. Character, creator, character. And we can use where to sort of get back specific information. So let's say we want to reference the character ID column, say where character ID is equal to like 55 or something. If we go ahead and run on that, you can see I get back 55, debit, blah, 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 and all the numbers as well. If I do 10, we get back the ID of 10. If I do 1, we get back the ID of 1. If I do 5, we get back the ID of 5. Let's say I want all of the characters where all the character IDs are greater than 50. Go ahead and hit run on that. You can see I have all the characters that are greater than 50. And it's the same sort of like greater than and equal than, it's all the same thing. So if, let's say I want all the characters that are less than 50. And see I get back all the characters that are less than 50, excluding 50, so up to 49, right? So we can do that. Maybe I can also sort of stack these where statements by doing, using the keyword and say we want where character ID is greater than 50, and let's say where character ID is greater than 10. If we hit run on that, you can see I get back 11 to 49. If you want just maybe, let's do 45, I can get back 4 values. Boom, 46, 47, 48, 49. Fantastic. So it's working as intended. Remember to include that semicolon though. Now, let's say we also want to, we can also use something similar to accomplish this. We can say where character ID is less than 50, or maybe we want to do where character ID is between, let's say 50 and 100. Go ahead and run on that. You can say get back all the values from 50 to 100, and in this situation it's inclusive. So we can see we have 50 here, we have 100 here as well. So between 50 and 100. If I want 101, it'll give me back 101, right? So between is another keyword we can use, and then we write comments in SQL as well by doing 2 dashes. We can say this is a comment that doesn't affect anything. All right, fantastic. So let me share that with you. And we did one more as well, which is from where character ID is greater than 50 and where character ID is less than 200. Cool. All right, so we got that so far. Now, we can also, maybe we want to go ahead and add some other things. Maybe we want to go ahead and sort. So let's say we wanted to sort all of these names alphabetically. Well, we can do that by saying where character ID between 50 and 100. We could stack that by saying order by, let's say, name ascending. So we want them in alphabetical order. So if I go ahead and do that and hit run, you can see I get back where name is ascending. So we got A, C, D, E, F, I, C, all of this stuff is here. So it's all ascending. If I do descending now, that's what this stands for. Then what we're going to get back is we're going to get back all of the names descending. If I want to do character ID descending, I can do that by specifying the column. It's a character ID descending, and we're going to start from the top 101, go all the way down. I can get rid of the statement. We can just deal with all of the characters, and you can see I can start at 302, go all the way down to 1. If I wanted to go ahead and do the same thing with the names and just have it organized by name, hit run, you can see I get back, and obviously the IDs aren't going to be the same in order because we're just referencing the actual, we want the character names to be in order. We don't want the character the character IDs aren't going to be in order. We can also do name ascending, so we just have it in alphabetical order. Fantastic. We can do any of these. If we wanted to do level, we can run that. You can see level is all just 0, so it'll just keep by default, again, aggregate by character ID. So perfect. So it's working as intended. Now, let's say we wanted to do something. Let's say we wanted to order this by something specific. What if we wanted to, or what if we wanted to group this by something specific? Let's say we wanted to group all of the names that have a repeat value of 2. How would we do that? So I'm gonna give you guys, I'm gonna go ahead and hand you guys a documentation. Yes, we can. We can figure out how many tables this SQLi3 file has. This is something we'll talk about later on tomorrow when we get into actually understanding the schema and stuff. But for now, I'm going to give you guys a little exercise. So I'm going to give you guys a SQLite documentation. And you should be using this today. And what I want you guys to do right now is I want you guys to, I'll share this with you as well. I want you guys to figure out how group by works. So let's say I'm going to go ahead and ask you guys a business question. And that business question is, because that's what a lot of SQL is used for, I'm going to ask up here, how do we get back how do we group names by how many times they repeat? So that is going to be your goal for the next 2 minutes. And I'm going to go ahead and say select star from, I'll say from character creator character table. So that's the table we want to be referencing. You're going to have to fill something in here and here. And the trick is you're going to be using the group by keyword. So what goes here and what goes here. All right, so that is what you guys are going to be working on for the next 2 minutes. See if you can figure it out. And then if you can, post it in the Slack channel. And I'll see what you guys have to say. So I send the documentation you need. 2-minute exercise. Let's see if you guys can figure it out. Did you guys figure it out? You got 2 seconds. Okay, so maybe 2 minutes wasn't enough time. Does anybody have any guesses? Paul, select name, count star from character, critter, character, group by name, order by count. Okay, let's go ahead and see if this works. Let's give it a check. Select name, count from character, critter, character table, group by name, order by count, start ascending. Boom, exactly. Well done. Good job, Paul. That's exactly what was going on. Yeah, good job. So what's going on here, though? Hopefully you guys had a chance to check out the documentation, but let me explain it. So what's going on is order by allows us to sort of order by some specific type of aggregation, some specific function. So in this instance, we're calling name and we're calling count. So for now, let's go ahead and just get rid of this. Let's get rid of uh, order by count and just make this as simple as possible. So let's run this. So right now, all this is doing is saying select name, count star. So what it's doing is it's going to be selecting each name, and then it's going to be using this count star function when we group by name. It's basically going to be utilizing count star and seeing how many times each name occurs. So if we say we have voluputat, which occurs twice, right? So it's taking the name and then it's counting the number of times that name repeats, right? So for this instance, we're counting how many times remex occurs, which is once, so how many times said patriarchal occurs, which is once, how many times each of these characters occur, right? And that's what this group by name is doing and what this count star is doing. So we need this some type of function here in order to see the total number of times, or see, not the total, in this instance, the total number of times, but see the function aggregated by some value here, right? And then this order by, all that the order by is doing is the order by is just saying, okay, we want to be ordered by count star, which is the returning value that we get here. It's this column. So count star, we want that to be descending. So we can have the highest values at the top, which are going to be 2. So these are the 5 names that are at the top that have been repeated. And that answered our business question. Now maybe we want to make this even nicer and just say limit by 5, since we know there's 5, and we get back just the 5 names that were repeated. Fantastic. Well done, Paul. That looks good. I'll give you a little bit of fire. Now we've done that. Now let's go ahead and see something really interesting with SQL commands. So notice how we get back a table from this. Notice how we get back a table when we just do something like count star, right? We get back 302 with one row with this table name or column name count star. Now, what SQL does is it sort of communicates through tables. When I go ahead and say select count star from character created character, basically what's going on is it's returning me a table. And there's this really cool thing called subqueries that we can utilize when we're writing our SQL commands. And what a subquery basically is it's utilizing the table that we got back from some initial query and then running an additional query on that table. So I'm gonna go ahead and go back real quick, and we're just gonna go to select name count star. So we're gonna learn about subqueries in a moment, but there's also something super important that kind of goes in line with subqueries, and that's sort of alias casting. So if we run this query, we get back name and count star, which is the total number of times it's repeated. We can cast this count star as a new column name by saying by using the as keyword, and this has to be capitalized since it's SQL syntax. We can say count star as, and we can cast this column name as something that we want. We can maybe, or a table or whatever it might be. It's basically just sort of similar to the Python import. You know how we can cast things as aliases there by saying import pandas as PD or import numpy as NP. Same thing here. We can say count star as total repeated. If I go ahead and hit run, you can see I now get back total repeated here for the count star value. And then I can reference it as total repeated down here. If I hit run, you can see I get back it's organized by total repeated. So that's some nice variable. That just makes things look nicer when we're referencing stuff. Okay, cool. So let's say we got back this information and we want to run a subquery on it. Well, we can do that by wrapping this whole thing in parentheses and saying select star from this table. So similar to how how we have this from character creator character table and we're referencing a table, we can do the same thing with some subquery some table that we're getting back from some query, right? So for this instance, and this is called the subquery, we can say we want to run some test on this query that we got back or some SQL on this table we got back. And we're going to want to finish this off with a semicolon, but we are basically just going to grab everything we have here. So if we see that, we get back everything we want. But let's say we want it to be a little bit more specific. We want to say where select star from this query, this table that we get back, where, total repeated is greater than 1 or something like that, right? If we go ahead and run that, see, we get back all the values that are 2. We don't even need this order by statement anymore because we could just run this. So if we go ahead and run that, it works perfectly fine. Now, I'm sure what you're saying is, oh, why do we need this subquery? We could just do this. It'll work just as well. Well, I need to actually organize this properly. I think DB browser might have some issues with this, or SQLite. I think you can do this in Postgres. We're going to talk about dialects tomorrow, about SQL dialects, but as I mentioned, it doesn't work. So at least in terms of SQLite, we need to actually reference the table for it to work properly, at least for SQLite, or maybe it's just DB browser that's giving me issues. But subqueries basically allow us to run additional queries on top of the table that we get back. And this is specifically useful with joins. So I'm gonna go ahead and share this with you. So this is specifically used for joins. So let's say we want to join 2 tables together on some ID, right? We can do this by saying select star from character creator character. And then what we can do is once we've selected star from character creator character, we can say we want to inner join on character creator fighter. All right, so this is going to inner join character creator character on and character creator character and character creator fighter, but we need to specify what we want to inner join on. So we can say on, we want to inner join character ID on character ID, specifically character PTR ID. Okay, and then we can reference this and we can say this as CCC, as CCF, and we can go ahead and say CCC dot character ID just so it's not confused and we know exactly what we're talking about. We can say, okay, we know that we're referencing the column from this table and referencing the column from this table. If I go ahead and hit run, you can see we get back these 2 things joined together. So we get back, and what this is basically doing is we go ahead and pull out the PNG of our schema. Come down here. You can see we get back. What we're doing is we're linking character creator character and character creator fighter. So we're basically interjoining the IDs that show up in character creator fighter. Because right now, if we just look at fighter, it just has using shield and rage. So what we're doing is we're interjoining character PTR ID with the IDs that match in character IDs. And then we're adding all of that information with the associated character ID to this table. So if we look back, we only have, it seems the first 58 values inside of our character creator character table are fighters. That is their class. So if you see, we now have a using shield and rage value associated with each of these characters, right? Which is really cool because that means that these are the fighter characters. If we did the same thing with something like mage, and I run this, we get back new values. Instead, we get back 69 to 302. Wait. Oh, maybe we get, okay, so actually, I guess it's not in a row. We just get back a collection of different random mages because those are the mages in character creator character table. All right. And some of these are probably necromancers. I'd imagine these ones are probably necromancers. But yeah, and we can do the same thing with thief if we wanted to, but you can see that we are now basically adding together two different tables. And getting that information. And what this inner join does is I'm going to go ahead and send you guys something you should check out. Types of joins. This is a nice little article that explains the types of joins. And this one as well is pretty nice. So check that out. I'm going to give you guys a brief description of what they are right now. We have a bunch of different types of joins. So let's take a look. So we have inner joins. What inner joins basically do is the red is the stuff that's excluded, the green is the stuff that is included. What a inner join does is it basically takes all of the values that match, character ID equals character PTR ID. All of these data values that match are going to be stored in this new table that's created. So character ID, this column right here, all of these little IDs that are stored here, all of them, are found within the character PTR ID. So these IDs match up, as you can see. 59 is not in here because 59 does not, it's not in character PTR ID. They need to equal each other in order for it to be shown. That's an inner join. A full join would capture everything. If we full joined both of these, we'd get back all of the data values. And then for the areas where it's not, is sneaking and energy and stuff like that, it would be null. There wouldn't be any values there. Left join, basically it's right join, left join are pretty similar. Left join basically just says, okay, where character ID exists, we're going to include those values even if it does not equal the character PTR ID. So if we left joined this way, this is the left value, then what we'd get back is 302 rows. And if we just right joined on this, we'd get back just how many rows there are here, because that is the total number of character thieves there are. So that makes sense. That might be a bit confusing, but like I said, these articles are very good at clearing them up. But we've gone ahead and joined together two tables. And what's really cool about this is we can now perform some type of subquery on it. So I can say select star from this table. Maybe I just want to select some specific stuff. Maybe I just want to select name and character ID. I can do that. I just get back the name and character ID. Fantastic, because I'm selecting from this table. Now let's say we want to select everything, and maybe we want to run some aggregation. Maybe we want to, or not some aggregation, maybe we want to do some functions on this new query that we get back. Well, we can say, all right, select count star. Let's see how many different thieves there are. And this is sort of a roundabout way of basically just doing select count star from character creator thief, but it still serves my purpose. It's 51, so we have 51 thieves. Now, let's say we want to get the average, what if we want to get the average, I want to get the average energy of a character, so we can say AVG, which stands for average. We want to do it on energy. And we want it from character creator character, but we also want to print out the associated character ID, which is something that's not found in the thief table. And let's also say we want to print out the level as well, something also not found in the thief table. We can do that. We can get back the average energy. Oh wait, we need to actually sort by something. Let's say we just want to get back the energy. We have the average energy here, which is 100. Let's say we just want to get back the energy, character ID, and the level. But we can do that because we've interjoined. So I have energy, character ID, and level, and we can get back the name as well. And I have the name too. Notice how it's in the order that I specified these columns that I want to reference. But that's pretty cool, right? I can also do a where statement on this, and we can say where energy, or where all these values are the same. We can do where character ID is greater than like 200 or 250 or something. Get back all the values that are greater than 250. So cool. So this is how we do these interesting kind of subqueries, and we can make this look even nicer. We can say maybe we want to indent this. We can hide subqueries as well. So that looks pretty good. We run this, same thing happens. Fantastic. I'll share this with you guys. Cool. All right. Now let's say we want to let's do another inner join. This one's going to be a little bit more difficult. Let's see how can we tell how many items each character has? How would we go about doing that? So first we probably want to inner join a couple of things. Or how about we do something a little easier? Because I think that's actually a question. How about we see the inventory of each character? So first we're probably going to want to inner join. So I'm going to say select star from character creator character. Let's pull up our schema, and we want to inner join on character ID and character creator character inventory. So I'm going to say select star from character creator character. I'm going to go ahead and say, so we want to select star from character creator character. We want to inner join where character creator character inventory is, character creator. Oh gosh, character creator character inventory. Cool. All right, so we're going to go ahead and do that. Now we're going to go ahead and specify a couple more things. So we have our character creator character inventory. We have our character creator character. Let's go ahead and inner join on character creator character ID and character ID. We need to specify the type of character ID. So let's go ahead and cast this as CCC. Let's cast this as CCCI. Should be uppercase. So we can say CCC dot and CCCC dot CCCCI dot character ID colon run. And we get back all of the different items. Notice how there's repeats because character ID is going to be repeated multiple times, and it's going to have an item ID. So as we can see, aliquad has 3 items, and this is the item ID associated with that. All right. So what if we just wanted back what if we wanted to get back the total number of items that each character has? Well, we can do a subquery and say, okay, select name and then count item ID from select character SCCI on this. Cool. And then we can go ahead and say, all right, where or order by count or item ID. Let's actually not item ID. Let's count this. Let's call this total items. All right, let's run this and see if it works. No such column item ID. Let's do CCCI dot item ID.
I think you're just missing the I in ID.
Oh,
Line
yes,
1.
yes, I see it. Thank you. Okay, I'm missing the I. Cool, thanks. Oh, item dot ID, gosh. All right, there we go. It's hard to see anything with these red underlines. Perfect. Look, so we got back name, aliquad, total items. Oh, this is supposed to be average. Oops. Or, no, it's not. It's supposed to be count. Sorry. All right. So we're counting back. So what's going on here? What's this error we're getting when we do aliquad is say optios 393? Can anybody figure it out in the last minute? I'll give you a hint. It's related to how we're referencing the subquery. So we done the order by before. What's going on here? Why is it just counting the total total items, and then throwing this out? This is the last one we're going to do today. So let's see if you guys can figure it out in the last 2 minutes. Oh, this should be group by, my bad. I should probably run this. So what's the issue that's going on here? Well, it's pretty specific. It says it down here. Aggregate functions are not allowed in the group by clause. We're not grouping by count, we're grouping by name. We want to count each item that each name has. So this is a very common error as well that a lot of people fall into, is you want to be sure that you're grouping by the non function that you're referencing. So in this situation, when we're using the aggregate function, we want to be sure that we're not referencing the actual aggregate function itself. We want to reference the name that we want to order by. We want to order by name, so we want to order everything by name, and then each name we want an associated value, and that value is typically the function that you call upon it. For this instance, count, right? So if we go ahead and run this, we get back each name and the total number of items they have. And then we can go ahead and say order by, and let's order by total items. We can reference that now, say total items, and then go ahead and hit run, and we can see that we get the total items ascending. Let's see whoever has the most at the top, and we get back that debit has the most number of items, and he has 7. So that's how we do this nice little query. We say a group by name, order by total items. So just remember that this should be referencing a column that already exists, and it already exists. This one has yet to be exited or created because it's sort of a function is being called on it, but name exists here, right? Does that make sense? Yeah. Any questions about what's going on? I'll share this with you as well. No, that makes sense. Okay, cool. Well, your assignment today is just going to be basically writing these queries, and sort of specified here is writing these queries and answering these business questions. Like, how many total characters are there? You've done this one already. How many of the items are weapons? How many items are not weapons? How many items does each character have? Kind of already did this one for you. In fact, I'm going to delete this just so you guys don't have the answer and you can figure it out by yourself. But that's essentially what we're doing. All right. Cool. So I will let you guys go. Good luck on your assignment, and I will see you tomorrow. Bye.